Hello, in this video I'm going to show the work I did for stock market prediction, where I actually tried to predict whether the stock actually is going to go up and down. I did build like a few different model and tried different approaches to find the stimulant and the best feature to pick to find whether like the stock market prices for specific stocks that I actually targeted is going to go up or down the next day. So here's the outline that I'm actually going to go through. So stock market actually prices, it's kind of hard to predict, uh, and it's still like an active research area, and a lot of businesses and academic persons actually try to build models and find the best stimulant to all of that, because the financial gain obviously for that area in there. Building an accurate prediction model is still like a challenge. Um, Based on the efficient market hypothesis, which actually say that the stock market like follows a random walk pattern, so it's kind of really hard to find a pattern to use to predict the model. Several people have attempt to extract pattern that affect the market from different stimulant. Like some actually use Twitter, some use like Reddit and like news from like Yahoo and all that. Finding the best time to buy or sell stock, it's still like a difficult task, since many factors might influence the stock price. In my research in here, I actually used Twitter as the main source to find information and to see the stimulant from Twitter, um, where actually the stock actually going to go up or down for the specific stock that I actually targeted. And one of the biggest reason I use Twitter, like it's actually one of the biggest market stimulants today. That actually talking to few people that did like work on and actually gain money from stock market actually tell me that they use Twitter. And also we can see that Kelly Jenner actually tweeted on February 21, 2018, that she does not like Snapchat anymore. Just because of that tweet, Snapchat actually had 6% decrease in its stock price and caused them roughly like 1.5 billion loss in market value. Some previous work actually been done. Uh, many of the previous work been targeted like one stock, and they used actual sentiment analysis to find whether that stock actually goes up or down. Other actually use like do industrial index price, which is actually a combined market value, a combined 30 stock of the biggest market value in the US, and use like news that and see if these news actually will affect all these market value at once. Um, some people try to use like multiple sentiment models and then take the majority vote of them. Many research aim to predict only one. Few research, however, did implement multiple stocks prediction, where they used like some actually used 18 stock or less and collect their tweets and sentiment over a period of only a 1 year. Uh, One other thing I would like to say, that's for my actually approach, I used a longer period of time. So I actually target tweets from 2008 until 2014. So I actually target a much larger range of time. And plus, actually, I tried to target 63 stock market at once. So the data set I actually collected from Twitter um, had it's one of the kind of hardest part that I actually had to go through to collect. I had them as text, and from the where Twitter actually used the dollar sign as the character to index like the stocks, specific stocks prefixes. So I use these. I use this character to go and kind of collect the data I want. And also I did get an historic stocks price for each targeted company that I actually am looking for. And also, I did collect Reddit news dataset with uh, do industrial index historical price dataset too. And those actually I did to compare my first model uh, that used sentiment analysis and few other kind of methods with the second model that will use like Reddit with do industrial index and see and compare different stimulants that actually affect whether the stock's gonna go up or down. The CPLD model, which is actually just a prefix for controller, uh, collect, process, learn, and then data. So it's basically uh, based on 3 layers. The first layer is just the data set collection. So it's actually gonna it's the layer that's actually gonna go and get the data or like having an API and have all the connecting component in there from like the internet and all that, or maybe like from the database or from any source that we're actually gonna get the data from. Layer 1 is where actually we're gonna start to prepare the base data. So the base data is a huge data that actually has all the information we might need for any method that we might think of like later on. So it's just like a huge feature list of data, and then we can go and pick the feature that we actually want from this layer. The layer 2 is where we're actually gonna start building our methods. So like for example, like I want to build like a method for like sentiment analysis. So that's like we can call that method 1, and then build the data set from the base data from layer 1, and then find the method or the feature we want, and then from like for example the text, and then from the text we're gonna do like sentiment analysis, and then get all these features, build them up, and then build the machine learning model from them. So the first approach, this is my first model that I created, which actually targeted tweets and stocks. So in this model, I have like tweet stocks as my layer 1, where actually I have the collecting data, like API and all that from there. And then layer 1 is the base data, what actually give the stock and tweet, and then combined each a tweet by day, and then for each day I combine that with a company name. So I'll have the company name or the company prefix, and then all the tweets split by date inside that company name. So that's the second part I have in here, and then I'll combine the full tweet per day. So like I'll have one each instance in my data is actually gonna be the full tweet list for that day, and then we'll have them kind of merged by double hashtag, and combine the line to the next day stock price. So I'll have the tweets for that day, and then the stock, and then the stock price for the same day, and then for the next day. And then from this data set, the base data set, I'm gonna start creating my method. So I actually had like 6 methods for this model. So the first method I use for this model is based on sentiment analysis of tweet text for that specific day. So it's a combination of like 9 main feature and then 1 feature, which is the targeted feature, which is where the stock actually gonna fall or raise. So I'm actually using like classification approach in here. The first feature is basically just TF IDF of the top 300 word, where they actually have a count of 55 or more. Then I'll have the stock name, positive word, negative word count, and then positive word sum, and then negative word sum. So the positive word count, it's actually I use like WordNet to like having the full text in there split by words and having tokenized, and then push that word to WordNet and find with whether this kind of word has positive, whether it's a positive word or a negative word. So it's like if it has like more than 50% that actually in the direction of positive, it will be a positive word, and vice versa. And the positive words sum actually is just a summation of like if some word actually might have like 0.8, and like from their positive like positive from WordNet that actually have based on the closest pair of word that they have, some might have like 0.6 and all that. So I'm actually having summation of all these kind of values which lead to these two features in here, the positive and then the negative one. And then the web mentions count. So I'm actually finding how many time like a web page been mentioned and find if it is actually a relevant feature. And then sentiment counter status, sentiment sum status is basically the positive word count and then the negative word count. If like the positive word is larger than the negative word count, it will be like a positive sentiment status. If it, and also for the summation, if the positive summation is larger than the negative, it will be positive, and vice versa. And for my second method, so this method does not consider sentiment analysis, but uses other features and mapping to build its model. The feature for this method, I use the same TF-IDF with 55 counts and more, and stock name. Also, I'm still using stock status, whether the stock actually fall or rise. Now I'm gonna have like number of a tweet count, so how many tweets actually being tweeted that day for that stock, and then the tweet length summation. So like let's say for that day I have like 10 tweet, I'll get the full summation of these and have that as feature. And then how many time that actually tweets say sell keyword, and how many times did they sell by keyword. And then the mapping that I actually kind of created is whether the tweet actually has an early to midday, with the timestamp for that tweet actually were most likely early to midday, or like mid to night or night to late. So I have early to midday like between 3 a.m. till like 12 p.m. And then 12 p.m. to 9, that's mid to night, and the night to late, which is 9 a.m. to like 3 p.m. So buy sell status is basically like I'll see like how many, if I have like more people actually telling me to buy the stock rather than selling it, I'll consider this as like the status of it as like you should buy that stock, and vice versa for the sell. So if I have like people telling me that I should actually sell the stock and have that as the higher value, I'll have it as sell. But many actually tweet might not have either of those and will have zero value for both, or like will have the same value for both, and in that case I'll just consider it like as nothing. So it does not actually tell me whether I should buy or sell the stock. So for the same model, the method 3 I created is the combination of method 1 and 2. So I'm testing whether it will result in a better result by combining these kind of features. So I'm taking the feature from both and combine them in one model. So after that, I move on to method 4, which all the previous model from 1 to 3, it's based on like the full 63 stocks, and it will depend on the data actually collected. So for me, actually, for some stocks I only were able to collect like an instant up to 5, or some actually less. We can see here we have like 5, we have 4. So if let's say this like stock instance in here, I have all of them like positive, so it will be kind of redundant where I actually could say that the stock actually is always going to be like great, so this stock is never going to go down, which is obviously like a wrong statement. So in this method I'm actually cutting down these instance, so I'm only keeping instance where I have like 100 or more instance in them, which result, so which result in only having like 42 stocks, which are listed in here, and with a total of 33,416 instance, where the previous method actually kind of result in 34,457 for the 63 stock. So from the same method, we use the same data to find the sentiment, stock price, time series. So this data in here, I reduced the chart to only include the 2008 sentiment, and then used the sentiment sum different and the sentiment count different. So that's basically whether the stock actually, the summation of the positive words is larger than the negative, or the count of the positive words is larger than the negative. So I use these as the feature in here with the stock closer price, and we can see that some actually have some really nice correlation where the sum difference, the sum count actually went really up, and then the stock actually market also goes up, where some actually was really kind of in different direction, but still afterwards actually goes up. And similarly in here, where it actually goes way down and then it goes up. So some actually have a really nice kind of correlation and kind of fit perfectly, and some might be a little bit different. So that actually shows us a really good view of how the different sentiment count actually work with the stock price. So for method 5 in here, I try to use like a rule-based approach. So that's kind of different approach from the one I used before. I also used the same data sets, the reduced data set I used in method 4, which actually only keep the stocks that have like hundreds instance and more. So in here I used like most common words and then used hypernyms. So hypernyms is just like the word like root. So let's say some like word, let's say million, that might be like a large indefinite quantity, and then definite quantity or integer, and then number, entity, and abstraction. So that's actually just gonna go to the root, and then I'm taking the most common words in the tweet, and then picking from these, I can find that I had like a positive word from the full list of a tweet, where it actually sum up to like 961,639 positive word. Where the term that I actually use as positive word is actually, since I have these tweet, and then if the stock actually went up, so that's my assumption that these words are positive for now. And then the negative words kind of similarly. For these both kind of words listed in here, I have an intersection word that both of them might have. So taking these intersection word out, we kind of end up with only 23,054 and 21,474. So that's much more kind of cut from the word list, other than the 22,244 word, and that's because some word, or kind of many of these words actually kind of repeat it from these lists in both of these, so it will even take out all the repeated word too. So that's why we actually left with these kind of smaller numbers. So this is the positive we can see in white, and then the negative we can see in black words, and this is before we actually go ahead and find the intersection. So we might find some word that actually repeated in both, like date in here, some other word, million, I'm pretty sure I find million too, yes, million, both in here. So you could find like many words that actually repeated in both of these lists. So after taking out all the intersection word, we end up with a much better kind of distribution of words. So in here, there is no kind of any similar word in both. So that actually we can say that these words a little bit more kind of through the positive side, and then these words kind of more to the negative side. And then based on my intuition and from reading the words and then have them sorted by the most frequent one, I go ahead and pick the word feature that I actually want to use. And then from the hypernyms too, I actually list them based on how many words are in that hypernyms, and then based on the hypernyms level too, and I go ahead and pick these hypernyms also. So method 6 in here is a little bit different also. I will actually try to use an LSTM model, which is the long shortest term memory recurrent neural network. So basically I took the full tweet set and then built in like an embedded model, and then from the embedded model I tried to have it as spatial dropout one dimension matrix, and then put that in the LSTM model. From the LSTM model, I'll have like a dense list where actually it's going to be like a neural network where it's going to connect all the input to the output, and then have the softmax as the activation function. So it will be able to support non-linearity in the model too, and then based on that, we'll have my prediction. So now we can move on to the second model from the CPLD model. In this model, I'm actually using stocks and news. So the stocks is actually the do industrial index stocks, which is actually this kind of really different model. It's just for me to test different kind of stimulants for the market. So it's also gonna have the stock list and then the news list, and then combine them by day. So each day will have its news, and each instance will be the full news for that day, and then the price for the do index, and then the next price, and then whether it's actually gonna fall or rise, and all these kind of features in there. And then also from the layer 2, I'm gonna go ahead and build my methods and find the data set and build my model and do my evaluation on them. Only 2 methods actually been implemented for model 2, since those are the ones that actually much more relevant and kind of really close to, and I was able to build this model for. The first one is similarly to model 1, method 1, which was based on sentiment analysis, where I actually still use that TF IDF top 300 words with a count of 55 and more. The stock name, which is mostly the DIJA index, and then the positive word count, negative word count, positive word summation with mention, and then sentiment count status, sentiment count, and sentiment sum status. So, and also I'm still targeting whether the stock actually gonna fall or raise. So it's still a classification problem. The second model, I still use the LSTM model that I used for method 6 in my model 1. But instead of actually throwing in tweets in here, I actually throw in the headlines of the news, and then I use the same approach to find my prediction. So let's go to the result and see how these model, what's the accuracy, and then all these kind of results. And then first I'm going to show how did I created the models, and then I'll go ahead and show the final result for these. So I need to close that. So to build the model, I actually used Weka to build the models in here. So first of all, I go ahead and this is my base data set in here, and you can find that the text is a string type. So I actually went ahead to build my TF IDF feature. I went ahead in the filter and used string to word vector, and then have all these value in here to have IDF transfer TF transfer to be true, and then the minimum frequency is 555. I use null stimmer, rainbow, and word tokenization. I have all these characters in here with the double hashtag that I actually added in the text previously from the previous from the base data set, and here I I actually don't need them, so I'll just take these out. And then word to keep is like 300 word. So from here I actually can go ahead and apply this model. And here we go. Here, how did I create these kind of list in here? So I could go ahead and then have this as my class, since I'm trying to predict that one. So first of all, I actually tried the J448 decision tree model. So it's basically I actually go and pick it up and try to build the model and start prediction. So I'm not gonna go and wait for the full data to be built, since actually that's gonna take a quite while. So the second model I used the IBK, which was the k-nearest neighbor, and I actually used the 3 nearest neighbor to find as the target. And I tried many KNN value, like between 6, like 2, 1. Like I find 3 actually is one of the best numbers that actually worked quite well and had the best accuracy score. And then also I tried the cost sensitive classifier. So I still used like I still use the k-nearest neighbor with the 3 KNN value, and then the cost matrix I actually had to build, which was like 5 for the positive, and then 4 for the negative, and then just to add these weight in there, and then use explicit cost matrix, and I kept all these kind of value the same. So the second or the third model, that's actually the fourth model that I actually used, as the bagging model. So I still used the bagging, and I still used the k-nearest neighbor with 3 KNN. I actually tried like couple or different classifier for bagging also. Like I found k-nearest neighbor to work one of the best method that actually worked for me, and I had like a really good result for this model. That's why I actually go ahead and pick that on up. And then I kept all the values kind of the same. Then the last model, which was actually just a vote model. So the vote model I used the J448. I used the k-nearest neighbor, and I also used the cost sensitive model with the APK model 2 with KNN 3. And then I have the average of probabilities as my combination rule. So that's how I actually got ahead and did my classifiers in there and try to find the model. So one of the other things I would like to show you here is my code base. So I had my data set in here. That's the CPLD model. So it's like, here's my collect model, which is layer 0. Here's my process model, which is layer 1. Here is my learning model, and then the model that I actually build my method off, which is layer 2. And then here's my D model, which is the data set that I actually will have the data set for. It will hold the data set for all the other models. So layer 0 will have the layer 0 data set, layer 1 will have layer 1 data set, and such and forth. So in here, like I have like for my model 1, I have all these data sets. For my model 2, I have these data sets. And here's my layer 1, which this is the data set, the base data set I created for model 1. This is the base data set I created for model 2, and such forth. So for layer 1, I actually have like my model 1, model 2, so I have my APA and Scrabber in here, and also could have that similarly to model 2. And this is we're actually going to connect it and get the data. And I might have also, like, if I have the data in the database, I could just have like the database connection kind of function in here and all that. So layer 1 is where we actually do some processing. So I have my prepare function. I kept these in here just to have them so to know. So if you actually install LTK, you still need these package to download and have. So from this, I actually got ahead and built my my data set that I showed you before, which was in here, my base data set. And then from layer 2, I started actually building my methods. So you can see in here I have all these methods from 1 to 6. So for each method I had like the data preparation task. So it will go and get the task, load them, and do all the manipulation and find the values and build the feature list that I actually want for that task. And then in here, there's my machine learning models that I actually built from Weka before, and I have all of them in here. And then I have my results also to show. So in this model, you could actually have like model layer 2, model 1, method 1, and then you could actually build your kind of directory, and then you build your project and your model like the way you actually like. The way I used is just to have, so it's not really an opinion. It does not have a really strict opinion of how you actually should build the data inside your method. So you could choose whatever it's much more convenient to you and build the data in there. So that's the best one I actually find that worked best for me, to have the machine learning model and the result in here, and then they have my data preparation. I'll come back to the result after I'm done with showing this model in here, and then for my also model 2, I'm trying to close that. So my model 2 is also the same approach that I actually used. So also you still have the configuration JSON file in here, where you actually have to go and point to the stock symbols, and this is the stock symbol that you actually want to target, and that's the stock's full name. So this is the stock's prefix, and then the full name that actually, if I find these in the text, I want to remove these names. And then yeah, the JSON file. So this is for the scrapper, so it's just to have the scrapper be kind of neat to the website. It does not actually over kind of call the website and causing like any issue with the server that actually we want to get the data from. So in here, like if I'm done with like the day period iteration, then the sleep between 20 to like 100 second, and also for the month sleep between 5 and 60. So choose these at random, and this is just like the scrapper millisecond throttle that they had in there just to be nice to the website that we actually try to get the data from. And then makes the tweets peer query. So when you query like the data, how many tweets you want to get, and all these feature in here. And also have the stocks symbols file. It's best to have the full path to the file. So if I actually try to import the file from like within like models or like method inside these layers, it's gonna be much neater and easier to go and get the data from. So let's go ahead and discuss the results. So in here, actually, for my method 1, for the decision tree, I find like to have it like 55%, 55.83, which is still not that good. It's still the best result I had from my method 1 was you can see in here is like the vote method, and also had an RC area of 611. So that's actually pretty good. Show that actually does a little bit more better than actually just random guessing. The F measure in here, we can find that it's 575. So that's still like a decent F measure that show that the model does not just go and pick at random. My method 2 also actually had a best result of 57.91 for the IPK K3. But when we actually compare it with our RC area, we can find that the vote method had the best RC area in here. Also, if we kind of compare it with the F measure, also we're gonna see that the IPK actually kind of showed the best result with 578. Method 3 in here actually, which is a combination of these two methods, did actually show a much better result. So it's actually had like a result of 58 percent of an accuracy, which, and also for the vote, actually it had an RC area of 616, so that was like a pretty good result. Also the F measure still was the APK with K3, which had it was 580. So that's a much better method than the previous one. So actually we can see that the combination of these kind of two features in here did actually lead to an increase in F measure and then accuracy score in RC area. Method 4, we actually kind of cut down the data. So these method, as I said before, might have like 5 instances or so, and if these 5 instances or for specific stock had only been like positive, then we can always say that this stock is actually always positive and always kind of goes up, which is not a true statement. So method 4, where we actually kind of cut down the data, like between to have only the 100, that's the stock that had 100 instances and more, which led that to a 42 stocks. We can see in here the best accuracy score was like 57.99, so that's really close to 58 that we actually had in here. So, and in this method we actually used the sentiment analysis, what we actually used for the method 1 here, and then we actually had an RC area of 579, so it's only like 0.1 between that and then the method 3, so that's pretty good result. And have an RC area of 612 for the vote in here, which actually show that it actually does better than random guessing. For the method 4 in here, I'm going to come back to it down a little bit to show each stock accuracy by itself. Method 5 in here, where we actually used a rule-based approach, and then the word and the hypernyms, most frequent word and hypernyms, actually did not show that the well of an accuracy score. And the best like F measure we had in here was like 557 for the vote, and then also for the RC area was 589. So it did not actually show that much promising result. Using the LSTM model, we still have like a 56%, which still did not show as much good result as what we have in method 4. Also for the LSTM model, I used the same reduced data I used in method 4. For model 2 in here, and the CPLT model, the first method, which was used in the sentiment analysis, had the best accuracy of like 52.99, which is really not that good as compared between the previous method we tested. It does not do a lot more than kind of random guessing, with 560 as an RC area, or 525 for the F measure. Also for the LSTM model, it showed like a really lower score and lower correctly classified item with 44%. So did not do that good at all. So we could just go ahead and dismiss these kind of models in here. And that's actually just to show the comparison between different stimulants using the same feature list and all that. So coming back to method 4, I actually ticked out like 10 instance for each stock, and use these to kind of to evaluate the model they actually create later on, to find how good that model actually behave for each stock name. So I had like 42 stocks in here, and I used the APK with K3. So in method 4 in here, we had like the APK K3. We have like an 57 correctly classified item with 579 of an F measure. So using that model, we can see that some stocks actually did pretty good. Well, like Microsoft stocks in here actually had an accuracy score of 90%, where it has like an F measure of 916 and RC area of 889, where some actually did not do that good at all. Like the PIC did like 36.36 and actually had an RC area of 143 and an F measure of like 339. so did not do good at all. So we can see couple actually did like similarly to like 36%. I think that was the lowest score I actually had for the stocks. That was 36%. Some model actually did um, relatively like great kind of result. Like Apple in here, I had like 63%. PA had like 63%, 72 for but like company. So we can see in here that some model actually did, or some stock actually, we were able to predict them in much better than other, and that's also that was based on like 10 instant for each stock that I actually checked out later on before I did the learning to test the model. So in conclusion, many approaches have been taken in the same field in here. Most of them actually targeted like one stock, and we actually saw that some, if I actually target like one stock like Apple, I might actually have like a really good result, where some stock actually did like a really worse than like 36% and all that, where Microsoft actually did 90%. So picking one stock might actually give you a much better result, and then just targeting that stock. Having the do industrial index, for some research actually they were able to get like up to 70% using the Dow index and using the map and different kind of approaches, using also sentiment and some actually using mapping, but they have like a feature and they have like different data from different sources that they actually collect over like only a period of time, like a year or like a period of like 6 months and all that. Where some method actually where they actually target like 18 stock actually had the best result was like 54 for the average for all the 18, where did not show the average that my average was actually for all these stocks in here was 56%, with an average of RC area of 62854, and then a measure of 555. So my model actually did a bit more better, of like 56% instead of 54%. I actually should just put that on corrected. So I did like a 56% with the best model that I actually found, and target 18 was for 54%. Also in this model, I actually introduced like the CPLT, which the collect, process, and learn data model, which from actually going back and forth between the model and trying to build the model, I was having this kind of issue of wasn't able to organize my work much better. So I created this framework which actually really helped me organize my data and then have all the cluttered data kind of set, and was able to find my data really easily, and then using the configuration was able to kind of collect the data and get much better at speed of building the method and all that. So that should be it, and thank you for watching.